Dear students, our chapter is chapter 16, square root, part 5. At the end of this video, students will be able to 1. Solve equations using the square root. Number 2. Rationalize a denominator containing radicals. Materials we need: paper, pencil, calculator, your textbook edition 2012 or 2017. We know that if x squared equal to y squared, then by using the property of the difference of two squares, we can write x squared minus y squared equal to 0, which is equivalent to x minus y into x plus y equal to 0, and this is equivalent if we put each factor equal to 0, we get x equal to y or x equals to minus y. Examples. Number 1. Applying the above result to x squared equal 4, we get x is equal to 2 or x is equal to minus 2, and here of course this equation has two solutions. Number 2. Applying the above result also to 5x minus 3 all of it to the power 2 equal to 7. Here we know that 7 is equal to radical 7 squared, and we can write the above equation as 5x minus 3 all of it to the power 2 equal to radical 7 to the power 2. Then we get 5x minus 3 equal to radical 7 or 5x minus 3 equal to minus radical 7. Then by solving this equation we get x is equal to 3 plus radical 7 over 5, or by solving this equation we get x is equal to 3 minus radical 7 over 5. So in general, an equation of the form x squared minus a equal to 0, of course where a is positive, has two solutions or two roots: x is equal to radical a or x is equal to minus radical a. Application. Solve the following equations. Now student, pause this video and try to solve this application. Solution. Number 1. X squared is equal to 36. Then by applying the rule in the previous slide, we get x is equal to radical 36 or x is equal to minus radical 36, and so x is equal to 6 because radical 36 is 6, or x is equal to minus 6. Number 2. X squared plus 10 equal to 0, then x squared equal to minus 10, and which is impossible because any number to the power 2 must be always positive. Then the equation has no solution. Number 3. 3x squared minus 15 equal to 0, then 3x squared equal to 15. Dividing both sides of the equation by 3, we get x squared equal to 5, and so x is equal to radical 5 or x is equal to minus radical 5. Conjugate numbers. Given the numbers a, b and c, where c is positive, the numbers a plus b radical c and a minus b radical c are called conjugate numbers. Examples. A conjugate of 5 minus radical 6 is 5 plus radical 6. A conjugate of 3 radical 2 plus radical 5 is 3 radical 2 minus radical 5. A conjugate of radical 7 is radical 7. Application. Write a conjugate of the given numbers and calculate their products. Remember, a minus b into a plus b equals a square minus b square, where a and b are any numbers. Now student, pause this video and try to solve this application. Solution. Number 1. A conjugate of 3 minus radical 2 is 3 plus radical 2. Their product, 3 minus radical 2 into 3 plus radical 2. Apply the third remarkable identity. We get 3 to the power 2 minus radical 2 to the power 2, which is equal to 7. Number 2. A conjugate of radical 7 minus 2 is radical 7 plus 2. Their product, radical 7 minus 2 into radical 7 plus 2, also apply the third remarkable identity. We get radical 7 to the power 2 minus 2 to the power 2, which is equal to 3. Number 3. A conjugate of 5 radical 2 plus radical 3 is 5 radical 2 minus radical 3. Their product, apply also the third remarkable identity. We get 5 radical 2 squared minus radical 3 squared. This is equal to 47. Finally, 4. A conjugate of minus radical 3 minus radical 6 is minus radical 3 plus radical 6. Their product is equal to minus radical 3 power 2 minus radical 6 to the power 2, and this is equal to minus 3. Conclusion. The multiplication of two conjugate numbers is equal to a rational number. A rational number is a number that do not contains radical. Rationalizing the denominator. To rationalize a denominator of a numerical fraction, multiply the numerator and the denominator by the conjugate of the denominator. Examples. Number 1. To rationalize the expression radical 5 plus 1 over radical 5, we multiply it by radical 5 in the numerator and radical 5 on the denominator. So we get radical 5 into radical 5 plus 1 over radical 5 times radical 5 is 5. Number 2. To rationalize the expression 3 minus 2 radical 5 over 2 plus 3 radical 2. Here we multiply the numerator and the denominator by the conjugate of the denominator. So what is the conjugate of 2 plus 3 radical 2? Is 2 minus 3 radical 2. So we multiply here in the numerator by 2 minus 3 radical 2 and in the denominator by 2 minus 3 radical 2. We get 6 minus 9 radical 2 minus 4 radical 5 plus 6 radical 10. Here we do not forget to use the distributive property. First by first, first by second, second by first, and second by second. Here we apply the third remarkable identity, 2 square minus 3 radical 2 square. This is equal 6 minus 9 radical 2 minus 4 radical 5 plus 6 radical 10 over 4 minus 18. The final answer is 6 minus 9 radical 2 minus 4 radical 5 plus 6 radical 10 over minus 14. Application. Rationalize the denominator in each of the following expressions. Now student, pause this video and try to solve this application. Solution. Number 1. 3 radical 2 over radical 7. This is equal 3 radical 2 over radical 7 multiplied by radical 7 over radical 7. We get 3 radical 2 plus times 7 over radical 7 squared, which is equal 3 radical 14 over 7. Number 2. 1 minus radical 3 over 2 plus radical 3. We multiply the numerator and the denominator by the conjugate of 2 plus radical 3, which is 2 minus radical 3 over 2 minus radical 3. Here multiplying the numerator by numerator denominator by denominator, we get 2 minus radical 3 minus 2 radical 3 plus 3 over, here we have a plus b into a minus b, we get 2 square minus radical 3 square. So the final answer is 5 minus 3 radical 3 over 4 minus 3. We get 5 minus 3 radical 3 over 1, and the final answer is 5 minus 3 radical 3. Assignment. Review from the textbook, pages 182 and 184, edition 2017. Your homework from the textbook, exercises 14 parts A, D, H, J and K, and exercise 15 part A, page 190, edition 2017. Summary. We've seen from the previous videos a definition of the square root, and a negative number has no square root, how to find the positive square root of a positive number using calculator, and if A, B are positive numbers, C and D are any numbers. We have seen operations on square roots, how to perform product, quotient, addition and subtraction on expressions containing radicals. We have seen also expand expressions with radicals, expand using remarkable identities, and expand using the distributive property. And in this video we have seen how to solve equations using the square root, equation of the form x squared minus a equal to 0, where a is positive. Then this equation has two solutions or two roots, radical a and minus radical a. Also we have seen how to rationalize a denominator containing radicals, given the numbers a, b and c where c is positive. The numbers a plus b radical c and a minus b radical c are called conjugate numbers. And to rationalize a denominator, multiply the numerator and denominator by the conjugate of the denominator. Thank you students for watching this video.